and this is going to be your best revision class. Now in this, I had started with the science and technology module, in which we have already completed 3 lectures, and today we are starting with our 4th lecture, and in this we are going to prepare the theme called as space technology. Okay, now before I start, a notification from Naranaya's Academy that our 1-year and 2-year courses are active. If you want to take admissions, you can go through the details. You can click on the link provided in the description box, and you can get all the details regarding our 1-year as well as 2-year courses. Okay, now today we are going to deal with space technology. Now it's a substantial section because you see, UPSC has been consistently asking questions on space technology. You see, in the last 10 years, 11 questions have been asked. That means almost one question every year is being asked. So you should prepare this theme thoroughly. Now, look at some previous year questions from this theme to get an idea about the kind of articles we need to prepare, the kind of content we need to prepare. Now, see this question asked in the year 2016. What is greased lightning GL10 recently in news? Now, they have just given a terminology. Okay, and a simple question has been asked. What is it related to? What is it exactly? A simple one liner. Now, this could be something made by China, something made by ISRO, something made by NASA, whatever. Very easy question. Now, another question from the same year. Mangalyaan launched by ISRO. Now, they have given some factual statements, whether it is also called as Mars Orbiter mission. It made India the second country to have spacecraft orbit in the Mars after USA. Now, whether India is the second country or third or fourth, that's something we need to think about. And it made India the only country to be successful in making its spacecraft orbit the Mars in its very first attempt. Now see, very simple questions. Now this is not a very technical question as such from the science and technology perspective. But you should know what is Mangalyaan. You should know the basic facts about it. This is what we understand from this particular question, right? Now, here we have a technical question. Now this is specifically about PSLV, GSLV. So this is talking about the launch vehicles India uses. PSLV, GSLV, GSLV Mk3. Now here you see technical question. Technical statements are given. So from all these previous year questions, we understand that whatever is there in the current affairs, you need to prepare the basic facts, the conceptual facts, as well as some technical aspects. Okay, and sometimes one-liners will also be there in the question. Clear? Now, let's start with the first article of the day. Okay, in the space technology, many things are happening continuously. ISRO is doing something, NASA is doing something, China might be doing something. So space technology remains in news. Now the first article is related to small satellite launch vehicle. Why it is in news? Because if we have ISRO has a commercial arm, a commercial wing, a special company which deals with the commercial dealings. That is named as New Space India Limited, NSIL. Now this NSIL, in collaboration with Australia's Space Machines Company, so both are collaborating, and NSIL is helping us launch this 450 kg satellite. Now they are sending a satellite, but here they are planning to use SSLV, that is Small Satellite Launch Vehicle, and not PSLV or GSLV. Now for the basic part, we have got something called launch vehicle. Whenever we want to send something in the space, we need some vehicle. That vehicle is called as launch vehicle. Okay. Now this launch vehicle, as far as India is concerned, we have this launch vehicle called PSLV, that is Polar Satellite Launch Vehicle. We have another one called as GSLV, which is much stronger than the PSLV. The name is Geosynchronous Satellite Launch Vehicle. And there is one more version of this GSLV which we call as GSLV Mark III. It's an upgraded or advanced version of the same GSLV. Okay. As far as basics are concerned, we have PSLV and GSLV. But now we are talking about something new, that is SSLV. Understand the basic difference and then we'll look at the technical parts. The basic difference is PSLV can send larger satellites, big satellites, or even multiple satellites to the space. Same task can be done by GSLV also. I'm saying GSLV is much more stronger, much more advanced, and when we are sending a satellite to a longer distance, in that case, the payload capacity or the amount or the size or the weight the launch vehicle can carry, if we compare that, then GSLV will have higher capacities. Okay, both can send larger satellites, larger stuff in the space, or both can send multiple satellites in one go also. So you must have heard this news many a times from ISRO, that they have made a record wherein ISRO has sent, let's say, 50 or 100 satellites in one go. This is possible. Now we are talking about something called SSLV. The name itself is small. When we say S, it is talking about small satellite launch vehicle. So in case I want to send a small satellite, not a big one, a very small, let's say 100 kg satellite, 50 kg satellite, 200 kg satellite, okay, or let's say I have to send just one or two satellites, not more than that, not 50 or 100. In that case, if we wait for a PSLV to be built, it will take a lot of time for PSLV to be built. Every time we have to build this entire launch vehicle, right? And there will be lot of space available. So what usually ISRO does is it waits for all the dealings to come. When they have got, let's say, 30, 40 or multiple satellites, then they send this PSLV, because it is very costly also. So putting multiple satellites makes it bit cost effective. But let's say you're getting a commercial deal from a company. They're saying that send our satellite as soon as possible, just within next few days, just within a week, or let's say within 15 days. We are going to pay for you. Then in that case, it's better not to go for PSLV, not to go for GSLV, rather go for a new kind of launch vehicle, which we call as small satellite launch vehicle. So it's a small one as compared to PSLV and GSLV. It's a smaller launch vehicle. It can send these satellites which are of smaller size. It can also send multiple satellites, but there will be a capacity range which is lower. And obviously, as compared to PSLV or GSLV, you can build this SSLV in a very less time period. You don't need much infrastructure. You don't need so many people, so many technicians, scientists, etc. You need less, and everything can be built easily. So in case any dealing is there, on demand dealing is there, that can be dealt with very easily using this SSLV. So right now we are talking about commercializing space activities. ISRO is looking for getting some deals from private companies. So SSLV would be a good choice for those companies to choose ISRO. Okay, now as far as ISRO is concerned, as far as SSLV is concerned, till now it was in developmental stage. So we did multiple experiments. For example, in 2022 we did this SSLV D1 experiment that failed. But later on in 2023, SSLV D2, that was successful. 3 satellites were sent 450-kilometer circular orbit, in this 450-kilometer circular orbit. So it was successful. Okay, so now we are looking at SSLV, that it will be of help for us. Now let's go back to the factual part of other launch vehicles, and then we will compare it with SSLV for complete understanding. Okay, let's take PSLV, Polar Satellite Launch Vehicle. Now, in case you want to send a satellite in the polar orbit, okay, there is an orbit from our North Pole to South Pole. Likewise, this orbit is there where satellite will be continuously moving, and it will track all the parts of the Earth. Now this is polar orbit. Then we have another GTO. Let's say you want to send a satellite to geostationary orbit, which is way far, 35,786 kilometers, that far. So there also, to send there, we use one orbit called GTO orbit. Okay. Now in both the orbits, if you want to send a satellite, you can certainly use PSLV. Okay. Then GSLV, it is specifically used to send satellites in the GTO orbit or the higher orbits. We have specially designed it for the same reason. Okay. And obviously, its upgraded version or the most advanced version, we even call it Bahubali rocket, that is GSLV Mark III or LVM3. This is specifically for sending satellites in the GTO, geosynchronous transfer orbit, that too the satellites which are having very heavy payload. If you have something very heavy, in that case you will use this GSLV Mark III. Clear? Now look at this thing. The first flight of PSLV took place in 1993. This one GSLV came in 2001 and GSLV Mark III 2017. Now look at these stages. The stages are very important. You look at any launch vehicle. When you look at this launch vehicle, it goes into the space in different stages. The rocket itself, the launch vehicle itself is built in different stages. Let's say this is your stage 1, this is your stage 2, this is your stage 3, and this is your stage 4. Let's assume. So I am saying there will be a separate fuel which is available in this stage 1. There will be a special oxidizer. The fuel will burn and the entire rocket will move because the fuel over here is burning. Once the fuel is burnt completely, this part will fall back, will get detached from this entire rocket and fall back on the earth. Okay, and only this remaining part will move. How it will move? Now the second stage will become active. Whatever fuel is available in this second stage, it will start burning. Similarly, after some time, once this fuel is exhausted, second stage will fall back. Similarly, the thing will happen for third and fourth stage. Okay, and in this last stage, you will have your satellite over here at the top that will be pushed in that particular orbit wherever we want to put it. Okay. Now, as far as PSLV is concerned, we have PSLV in total 4 stages. Okay, it has total 4 stages. And if you look at all 4 stages, the first stage has solid fuel, second stage has liquid fuel, third has solid fuel, fourth has liquid fuel, alternative. Now this fuel also matters. When you take a solid fuel, it burns quickly, it gives very strong thrust, means when this rocket is supposed to leave the earth, it gets very strong thrust because it has got solid fuel. Okay, then when we see all these fuels are there, now compare it with GSLV. GSLV has got only 3 stages: solid fuel, liquid fuel stage, and third is cryogenic. Okay, and now GSLV Mark III, because it is the upgraded version of the same GSLV, it will have the same fuel type. Okay, solid, liquid, and cryogenic. Now look at the payload capacity. I told you PSLV, as compared to PSLV, GSLV will have payload capacity which is higher. See it in the SSPO, Sun Synchronous Polar Orbit, it can send the payload up till 1750 kg. Very good. And in GTO, it can send 1425 kg. Compare it with GSLV. Instead of 1750, it has 2250 kg in the GTO, and in LEO, it can send, or low Earth orbit, it can send 6000 kg. Now that becomes even higher over here, 8000 and 4000. Okay. Now, if you want to know some examples, well, we sent Chandrayaan 1 or our Mangalyaan mission using PSLV. We sent many GSAT series satellites using our GSLV. And this Chandrayaan 2 and Gaganyaan, which we are planning right now to send some astronauts in the space, that is being planned using this GSLV Mark III launch vehicle. Clear? These traditional launch vehicles, we are clear about it. Now understand the things for SSLV. Small Satellite Launch Vehicle. Now this launch vehicle has got total 4 stages. Okay, total 4 stages, out of which 3 stages, all 3 stages, first, second, third, are having solid fuel. Okay, and the last one which remains at the top, that one is called as VTM module. VTM module, velocity trimming module. Now this is very interesting. Okay, all three are solid fuel, nothing new, nothing different. But here the fourth one is something different. What is so specific about it? Now this module will ensure that whichever satellite which you are supposed to put in a particular orbit, it will ensure that that thing happens in a very precise manner. So what it does exactly is, it is going to control the velocity or the speed of this entire rocket or the launch vehicle in such a way that when you are putting this satellite in the orbit, it exactly goes to the location or goes to that orbit where you want to put it. It becomes very precise. Okay, that is the special job of this VTM model. Okay, clear? Now see, we said 3 solid stages, solid propulsion stages, and the fourth one is your VTM. Now in this VTM you have got liquid proportional propulsion terminal stage. That means the fuel that you are using over here is liquid. So please remember this fact. 3 solid stages and the fourth one VTM module is having liquid fuel over here. Now for more details, I've also mentioned over here the exact fuel that we are using. The solid fuels that we are using in the first, second, third stage, it is this HTPB, hydroxyl terminated polybutadiene. Please try to remember this particular fact. Okay, and this VTM module has got the fuel which is liquid fuel. So it is having these two fuels, monomethyl hydrazine, first one, and the second MON3, mixed oxides of nitrogen. Okay, this is the technical factual part which we should remember. Now, as I said, SSLV is supposed to carry payloads of low size or low weight, not very heavy as such. So, what is the payload capacity of SSLV? Then, if you are sending a single satellite, in that case, you can send up till 500 kg of packages or satellites till 500 kilometers of orbit. This is possible. And in case you want to send multiple satellites, then from 10 kgs to 300 kgs till 500 kilometer orbit. So one more thing that we need to know, you can send one satellite, you can send multiple satellites also. But the range should be clear, 500 kilometers and 500 kgs. Okay. Now, what kind of benefits we are going to get? Now you anyway know the benefits. First of all, if you compare SSLV with PSLV or GSLV, the cost of sending a satellite will be very low when it comes to SSLV. You need less people, you need less infrastructure, you need less things. So considering all these things, you have cost which is low. Second, quick around time. That means to build up this SSLV, you need very less time. I said this every time we build these launch vehicles. So time is very less which is required. Multiple satellite flexibility. Yes, you can send multiple satellites, and minimal launch infrastructure needed, very smaller infrastructure needed. That's it. So this is all about your SSLV, small satellite launch vehicle. If you have any doubts, please ask, because this is a very important topic, I would say. Yes. Excuse me, Sai. Please give me the AC remote. Yeah. So now we'll head towards the second topic. Second topic or second article is related to Axiom mission, and this is a very famous mission, Axiom 4 mission. Why famous? One of the reasons why it is famous in India is because our group captain Shubhanshu Shukla, he has been selected to go in this particular mission called Axiom mission. Now he is Indian Air Force officer, and he is also supposed to be part of our Gaganyaan mission. In Gaganyaan mission, we are going to send few astronauts to space. This is our plan. But before Gaganyaan, we have our group captain Shubhanshu Shukla, who is going to space, who is going to International Space Station before Gaganyaan. And this is happening because of this Axiom 4 mission, which is being led by a private company. This is not initiative of ISRO as such. Okay, so you see, there is this company called Axiom Space from United States of America. This Axiom Space company is partnering with NASA, and they are going for this Axiom 4 mission. So there are total 4 missions already. 3 are already conducted. I'll show you. You see, Axiom 1 mission in year 2022, Axiom 2 23, Axiom 3 24, and Axiom 4 is scheduled in 2025. Okay. Now, what is the plan? What is the plan of this particular private company to go for Axiom 4 mission? The plan is to promote private space travel. Nowadays, we are thinking about commercializing space. The idea of space tourism. Space tourism is becoming reality, especially because of the entry of private sector in the space field. Okay, so many companies are emerging who are thinking about building space tourism sector. Okay, so here we see space travel, that too using a private company. Then commercial space station. Now they are even thinking about building a commercial space station. Right now we have International Space Station in the low earth orbit in the space, right? Even India is saying we are also planning to build our own space station, right? So here these people are thinking about a commercial space station, or let's say even a private kind of a space station. Okay, and also they'll do some kind of research, some scientific research they are planning. Now look at some features. The launch vehicle this Axiom 4 mission is using is SpaceX Falcon 9 launch vehicle. The spacecraft is SpaceX Crew Dragon. The key objectives are going for private human space flight, conducting some microgravity research. See, on the Earth, you can't conduct any microgravity research. You have gravity over here, but if you go to space, there's no gravity, or there's very less gravity. So you can conduct such experiments whichever you want to conduct. Okay, and they're checking whether we can build any commercial space station over there. Now, because this mission is leading towards International Space Station, that is ISS in short, we should know briefly about International Space Station. At least the basic facts we must be aware of. First thing, it was launched in the year 1998, and there are multiple agencies, multiple countries involved in building this International Space Station. Those countries are USA through NASA, Russia through its space agency called Roscosmos, Europe, entire Europe involved in this through European Space Agency, Japan through its JAXA, and Canada through its Canadian Space Agency. All these space agencies are involved in building this International Space Station. So it is not owned by one single country as such. Okay. Now the first crew was in 2000 actually. Now most important fact I would say is its altitude. You should know about this altitude. From the Earth's surface, this International Space Station is located at the altitude of 400 kilometers, and it is continuously orbiting. Now, the speed at which it is orbiting is 28,000 kilometers per hour. Just imagine the speed. It is, if you fire a bullet, compare that speed with this, you'll find that this one is high. Okay, so remember, try to remember the altitude and speed. This is an important fact. Now, International Space Station is there in the space. Okay, if you want to go to space, you can go and stay there. Now, my point is, it requires some electricity, some energy for that space station to operate. They need some energy. Now, they get this energy through solar modules. So, they have got 160 kilowatt solar arrays through which they are getting the power. Okay. And if you look at the entire design of this International Space Station, it's not like one entire space station has been built. Rather, it is built in different modules or different parts, I will say. Individual parts are made and they are assembled. That's why we call it a modular design. And because it is modular design, so we built one part, connected second, connected third, connected fourth part, connected fifth part. That's how we made it. So it is expandable. If we want to make it larger, expand it, that's also possible by building some more parts and attaching it. Okay, so modular and expandable design. Now, what kind of task this International Space Station is exactly doing? So as far as its research areas are concerned, so many astronauts, many scientists are there in the International Space Station. They are conducting microgravity experiments. They're doing researches in the field of astrobiology, astronomy, climate, material science, physics, etc. Okay, and because all these different countries are involved over here, what happens is there is a rule of law which is established over there in the form of mutual agreements between these countries or the international treaties. Those international treaties and agreements act as the law in International Space Station. Okay, I hope you're clear with this Axiom 4 mission, the timelines of Axiom missions, and you understand this International Space Station. Okay, please ask if you have any doubts, or else we will move ahead with the next article. Okay, I don't see any doubts till now. Good. Need a break? No? Now, the next article. This one is related to a concept called as gravitational lensing. Okay, now this is very interesting and many students get confused because it seems a bit technical, but it's very easy to understand if you understand it in a very simple language. Now, why this is in news? Because NASA has got one telescope called James Webb Space Telescope, and this telescope found out a galaxy which is far away from our galaxy. The name of that galaxy is Firefly Sparkle. How much far away it is located? 600 million years. I'm sorry. It is galaxy which is made 600 million years after Big Bang. Now the point over here which is mentioned is it's a very new galaxy. You look at the evolution of this entire universe. Evolution, if you observe the formation of galaxies, formation of planets, formation of sun, many things which are happening, this is happening since a long time. If you look at the Big Bang event, that happened long time ago. So if you see, many galaxies are still getting formed. Some galaxies have got destroyed. This phenomena is continuing. Now if you check which galaxy is older, which galaxy is younger, then you will see that this Firefly Sparkle is a very young galaxy. It has been created or it is formed just 600 million years after Big Bang. So it's a very new one compared to other galaxies. Okay. And NASA's space telescope, this James Webb telescope, has found out this using something called gravitational lensing. So this phenomenon of gravitational lensing is quite important for us. Now see what happens. One fact that we all need to know is, or we all already know about the phenomena of light. That light always travels in a straight line. Okay, light always travels in the straight line. Now there is a problem. The problem lies in the universe, wherein if you have some black hole, or let's say a very heavy kind of object, a very heavy galaxy, then it will have very strong gravity. See, Earth has got gravity, Sun has got gravity, entire galaxy has got some gravity, black hole has got gravity. Now I'm saying if you have something very heavy galaxy or a black hole, its gravity will be so strong that even if light travels in straight line, and here let's say we have a black hole over here, so it should travel in straight line, but it will not travel in straight line. Rather, the light will bend a little bit. This bending of light is the phenomena of gravitational lensing. So if you take the normal lens, the glass, the lenses we have, if you put the light, you'll see that light will change its direction a little bit, it will bend. So similar thing is happening over here. That's why this lensing word is being used. Okay. Now to understand it better, look at the objects or let's say the planets, or you can say galaxies, black holes which are present in the universe. Our normal understanding was the space is flat and gravity will attract. But studies have shown, especially if you check the Albert Einstein study, it shows that there is something called phenomena of warping. See, sun is having more gravity. It's a very heavy object as compared to all these different earth or any other planet. So you will see over here the flat plane will get warped over here, and this warping, this is leading to bending of light. If light is coming over here, it will bend at this particular position. Okay, so when we study about this gravitational lensing, we say that when there are massive objects, they create gravitational field which is very strong, because of which they warp the space time, and this leads to the light bending. Because there is a warped region, light will bend, it will get curved. Now when light is curved, now we have one problem. Let's say we've got a telescope, and through telescope we're trying to see different galaxies, different planets as such. Okay, now the light has an important role to play in this. Because of light we get the right image on the telescope, but because the light is bending over here, when the light bends, we don't see the right image. Let's say the size of this galaxy which we are observing is this much, but because the light is bending, we might see its size as this much, a magnified size, or maybe we can see a very small size, or even we can see multiple images of the same galaxy. We might see multiple images in the telescope. So this is one problem that we face when this light bends, and this is the gravitational lensing phenomena because of which this is happening. Okay, now why this gravitational lensing would be important for us? Because this phenomena, this is going to help us in many things, to study dark matter, to study dark energy, to study cosmic structure, etc. So many things we can study using this phenomena. Okay, so as I have mentioned that where is it, yeah, either you will get magnified image, or you will get distorted image, or you will get multiple images. You might get even an arc, or even something called Einstein rings. This was also in news very recently. So you'll get a new ring altogether, which is not present in reality, but because of this light, this ring is coming to this new object. So let's say this kind of a ring is there. This is called Einstein ring. Okay, because whatever study we have got that light doesn't travel in straight line, it bends and all, this is coming from Einstein's general theory of relativity. Okay, so this is all about the phenomena of gravitational lensing. Clear? We're done with this topic. If you have any doubts, please ask on this topic, or else we will just head towards the next topic. Okay, as far as facts are concerned, just remember this concept. There can be a one-liner question directly asked on the concept of gravitational lensing, or this path getting bent, the lensing phenomena, or this light, the light travels in straight line, but it gets bent because of these larger objects or heavier objects. And you should remember where all it could be helpful for us. You should remember this fact that Einstein's general theory of relativity, on this theory all this information is coming up. Okay, so we can say gravitational lensing is actually the phenomena which we are getting as a result of this theory. This theory has shown it. Okay, So all this you should know actually, and the result also. What happens in the result? This part, Einstein ring, distorted images, all these things you should know. You should remember as fact. Okay, done with this? Fine. Now we have the next news item that is related to the foreign direct investment in India with respect to space. So, India has come up with a new FDI policy with respect to space sector. So, I hope you understand foreign direct investment. We study in economy that other countries can invest in India, invest in the companies in India, invest in sectors in India. Now, different sectors have different norms. Some sectors are completely allowed for FDI. That means you don't need to take any permission of government to invest some money or invest your resources in that company in India. But there are some sectors which are a bit sensitive. What government does is it puts some restrictions. Okay. So as far as space sector is concerned, it was already a restricted sector. It was not allowed completely to go for investment in this sector by foreigners or foreign companies automatically. So there was some restriction, but now we are heading towards 100% FDI in space sector. This is the news. Now, what has government done right now? It's not like entire space sector is allowed for 100% investment by foreigners. There are some special rules made. One thing. So look at this. Up to 74% automatic route. Automatic route means you do not need government permission as such. So the investment till 74%, in which parts? The satellite manufacturing and operations, satellite data products, ground segment and user segment. In all these, if you're investing, then you can go for it up till 74%, not 100%. Okay. Then up to 49% automatic route for launch vehicles and associated systems, then spaceports for launching or receiving spacecraft. If you're building all these things, if there's a company, then you can invest up till 49% over here. You can take the 49% stakes in that company. Then you have got 100% automatic route. This you have got in manufacturing of components, systems, subsystems for satellites, ground segment, user segment, etc. So whenever we are building the components part, please remember this fact. Whenever we're building any components, any subsystems, we're manufacturing it. In that case, a foreign company can build its entire segment, entire company in India. You've got 100% automatic route allowed through FDI. Clear? Try to remember this part. Now, all this is being done so that the role of private sector becomes quite important in India's space sector. See, we all know that without the role of private sector, we might not see the space economy to grow. We might not expect the space sector to grow rapidly. So we want private sector to play some role. For the private sector to come in, Government of India has taken many steps. For example, they have made this Indian Space Association, ISPA, in 2021. Now this is an apex body or the main body for public-private partnership in space. So the public companies and private companies, they can collaborate, they can come up with some partnership through this particular association. Okay. Then we have got something called Anthrax. Okay, Anthrax. Now this is the commercial arm which is going for some deals with other companies, private companies. Then we have got InSpace Autonomous Nodal Agency, which facilitates private participation. So we have this agency too. Then government has exempted GST. There won't be any GST on satellites launched by private launch service providers. So this is a good initiative. The companies are getting incentive. And we have this India Space Policy of 2023. Now this policy is important because this policy categorically says that we are going to focus on private sector. Private sector is a key stakeholder in the space economy. This is what this policy very clearly says. So all these initiatives from government side shows that government is interested in the role of private sector in the space. Okay, so this is what this entire article is all about. Okay, new FDI limits. Try to remember these limits. Try to remember that it's not for all the things, but only for manufacturing these components or subsystems for which you have got 100% FDI allowed through automatic route, not the government route. Yes, if you have any doubts, please ask. Now the next and important topic. Now this is related to space debris. Have you heard about space debris? What is debris? See, we pronounce it as debris, not debris. Debris would be all these things which you observe. See, we are sending so many satellites, Indian companies, foreign companies. Now there are many private companies also. Earlier we had only NASA, ISRO, these government agencies. But now we have got so many private companies who are going to send many satellites, many systems, many spacecrafts in the space. Okay. Now, if you observe the surface of the Earth or this space part, there are many objects which are continuously moving in the space. Now, the satellites which we are using right now, certainly they are helpful for us. Okay, they are certainly helpful. But there are so many things which are not helpful. Let's say we sent one satellite. We sent one satellite in the space. And this satellite was supposed to serve in that locality. It was supposed to orbit the planet for let's say next 10 years. Okay, so let's say from 2025 to 2035. But what will happen after 2035? Nothing. This satellite, which has completed all its work, everything is done, now it's a useless junk for us. And this useless junk will keep on orbiting the Earth, orbiting in the space. It will keep on moving. And remember, they're not moving with a slow speed as such. The speed is somewhere around 28,000 kilometers per hour. This is a very high speed. Even if you have something very small, let's say we don't have a very heavy satellite as such or heavy payload as such, very small one, 50 gram 50 kg, 100 kg, very small. But still, if speed is 28,000 kilometer per hour, let's say because of some accident, this particular satellite or this particular object, it collides with one of our satellite, it collides with international space station, or it collides with anything, then it can damage, it can make a very deadly damage to that system. Okay, and we have got so many things. Let's say when we talk about space debris, we're talking about the dead satellites, the spent rocket stages. See, we talked about the rocket stages. Stages will fall, some stages will leave, will be there in the space itself. The collision fragments, sometimes the collisions take place, and because of collision more fragments will be formed. So one satellite and second satellite, they collided, then different parts, these are fragments, now they are also moving continuously. And discarded hardware, all these are part of space debris or space junk, and all these are useless for us, so nobody actually cares. Now if you see the data, how many such objects are there moving in our orbit, which are orbiting Earth? Somewhere around 23,000 have been tracked till now. Okay, the speed I told you already, their altitude is somewhere in the range of 200 to 2000 kilometers. That is in the low Earth orbit they are moving. Now, if we ask a question, which country has contributed more in forming these space debris? So the answer comes, number one is Russia, or we call it USSR, and then today's Russia, then USA, and then China. See, USSR and USA both have been competing since a long time. When it comes to space sector, these two countries have been leading. So historically, they have sent so many satellites, so many spacecrafts, and that's the reason their contribution in this space debris is way higher than any other country. And third number we have China. Obviously, after that, India will be coming up, right? And all the countries are concerned about this space debris, because if it falls on anything, then it would be very dangerous. Their mission will be affected very badly. Our satellites would be affected very badly. Now, see, the news item because of which we are reading the space debris says that International Space Station dodged space debris for 38 times since 1998. Since 1998, this is the 38th time this International Space Station, what they did is they dodged means they have moved some space debris. They have to do it because otherwise that would have collided on this International Space Station, causing a big damage or accident, right? So that's the reason entire world is getting threatened, is concerned about this orbital debris or space debris. Okay, now when we are studying this topic, for complete understanding, we should also know some of the initiatives taken by India or other countries regarding this space debris. If we are specifically doing something, because it's a big crisis, just like climate change, it's a big problem. Space debris is a big problem. So we have got some initiatives from India's side. Let's say we have this initiative called Project Netra. Project Netra. Now this is from India's side. Here we have built an early warning system. So in case there is a space debris which might attack or which might collide with some satellites or something might happen, we should know it early. So to know early, you have to track all those debris. So this tracking part is done under this Project Netra. For this, we have entire system of radars, telescopes, control center, data units, all these things are there. So what scientists will do, they'll clearly track all these debris. They will check their motion, where it might come at which point of time. All this will be done. Okay. Now this Project Netra is detecting objects which are having size more than of 10 centimeters. If you see the length, it's more than 10 centimeters. Okay, and the range in which this Project Netra will be active, it is somewhere around 3,400 kilometers. Now this Project Netra, with its components, with its all its data and all, it will provide us space situational awareness. That means what is exactly happening in space, which debris will come, which might collide with which one, everything you will get. And please understand this importance. Because of this Project Netra, we are somehow becoming self-reliant, Atmanirbhar. You're not dependent on other countries or agencies like NASA or Roscosmos. You will know on your own if there is any debris which is going to collide with your own satellite. We are concerned about our at least. So Project Netra, very important, I would say. Please remember this. Then apart from that, ISRO has set up this Center for Space Debris Research. Now to do some research on this debris, so study and manage all these debris threats. For that we have this center established by ISRO. Second. Third, we have this IS4OM system. The long form is System for Safe and Sustainable Operations Management. This was also launched by ISRO in the year 2022. And what it exactly does, it is going to monitor all these debris, It is going to predict if there will be any of the collision. It will predict all that, and it will try to mitigate these risks. If you already know that this is going to happen, then you can mitigate, you can stop it from happening, right? Either you move away that debris or you move your location. So whatever you want to do, you can do that. So this part is done by System for Safe and Sustainable Operations Management. Now, all these initiatives, all these measures, these are important for prelims as well as mains. The upcoming mains also, if there's a question on space debris, write down all these initiatives directly. And for prelims, obviously they are important. Okay. Then global measures. It's not about just India taking some efforts. Other countries must be taking some efforts. So for example, we have this liability convention brought under United Nations in the 1972. Now, what this liability convention simply says, let's say because of some satellite of India or some debris which is formed by India, if because of that any other country's satellite or spacecraft or anything gets affected, let's say one debris which is formed because of one of our satellite that collided with something which is sent by USA, their spacecraft, it is affected, that is because of that collision, that accident took place. In that case, who is going to pay for that compensation, whatever accident took place? Now it is the responsibility of India over here. This liability convention clearly says that the victim country can seek compensation from the launching state. Whoever has launched, from them you can take the compensation. The liability lies on them. Clear? So very important, liability convention. Then we have this Interagency Space Debris Coordination Committee, in short IADC, which was established in the year 1993. Now this is nothing but a forum where discussion can take place. So because space is something where we don't see any governance as such, countries are still exploring space sector, so there is a possibility of conflict in the space, fight in the space. That's the reason you need some dialogue, some forum where you can have dialogue with different countries. So this is a global forum, IADC, Interagency Space Debris Coordination Committee. Okay. Then European Space Agency has launched one initiative called Clean Space Initiative. Very good initiative. From the name itself you can understand. Clean Space Initiative. They are saying we are going to clean the space. Clean what? Clean the debris. So they want to reduce space debris and promote clean space activities. This is the objective of this Clean Space Initiative. Clear? So whatever we have understood till now, space debris, we understood what is space debris, what all it includes. We understood the factual part, number of objects, speed, and the top contributors. Is India the top contributor? Yes, we don't see it in the first three at least. Okay. Then the measures taken by India or ISRO to be specific, and at the global level what all is happening. So this is how we have tried to comprehensively understand this topic of space debris. Yes. Now if you have any doubt, please ask. We'll take a short break of a minute, okay, so that you also get refreshed and we continue with the next themes. So get your energy back. Just 1 minute break, not more than that. Till that time, if you have any doubts, you can ask. Yes, any doubts? Okay, fine. So now let's head towards the next theme, or the next article. Now this one is very easy. Square kilometer observatory or array observatory. Okay, square kilometer array observatory, in short SKAO. Very interesting name. What's exactly happening over here? Now recently it is in news because India has decided to join this SKAO. We want to become part of this particular project, and that's why we have joined it. Now there are multiple countries involved over here. There are total 10 countries who are part of this particular project. India is part of it. You should know these countries like Australia, Canada, China, India, Italy, New Zealand, South Africa, Sweden, Netherlands, and UK. And the headquarter of this particular project is there in United Kingdom. Now what we need to know is what is exactly this initiative, what we are exactly doing under this initiative. Okay, so we have got an array of some observatories. Now these are some observatories. Now these observatories are going to study what is exactly happening in the universe. Now see over here, this you see, this is your telescope, or in simple we can call it radio telescope. And for radio telescope you need an antenna. This is what this antenna is all about. Okay, now when we observe universe, when we observe any planet, we need telescope. Okay, and for the communication you require that antenna. Now this telescope could be of different types because each telescope observes universe in different electromagnetic spectrum. Let's say if we are looking at space, we might look it in the visible light spectrum, but there will be some telescopes made to observe universe not in the visible light, but let's say in the UV light. We humans can't see anything in the UV light specifically, or let's say something in radio waves, right? So every different telescope is made in such a way that you can observe universe differently and come up with the real data. Okay, now as far as this SKAO project is concerned, we call it world's largest radio telescope project. So it's a telescope which is going to make use of radio waves. Okay, and through the radio waves it will observe the entire universe. Now what all it is exactly doing, then I'll tell you this technical part, which is obviously easy. It is observing the universe. So first of all, studying the evolution of universe, its formation, its origin, how the universe exactly formed, how it started, from where it started, at which stage we are right now, and what is going to happen. So if you study the evolution, if you study the origin part, you can certainly know what is going to happen in the next time, or what is going to happen further. So this part is important. Second, it is going to study dark energy. Now, this dark energy is very important. See, there is some mystical kind of energy which exists in the universe. And this energy, we can't observe it. That's why we have named it dark energy, because Whatever telescopes we have, whatever we have, we could not observe this energy. That's why we called it dark energy. And now we are saying this energy is very mystical. This pushes the entire universe to grow, to expand. So there's something called expansion of universe. You must have heard about it. The universe that we are observing or we are trying to observe, it's not static. The size of this universe is continuously increasing. It is rapidly growing. That's what we call as expansion of this universe. And how this expansion is happening, the answer is given as because of dark energy. The dark energy is something very unique, very and the dark energy is there present in the entire universe. It is evenly spread, and this is leading to this expansion of universe. So now this SKAO is even supposed to study about dark energy and even the evolution of all the galaxies, how these galaxies have formed. Then it is going to study gravitational waves. So many times we get a news that there's a gravitational wave which has been identified. So we have some units, those LIGO units. There's a unit in India, also in many other countries. So they detect gravitational waves. Now, what this SKAO will do, it will try to identify the source location from where exactly that gravitational wave has come. So identifying its sources. Once you identify the sources or the origin, then you can understand the phenomenon of gravitational waves better. And even you can come up with information or data which can show a pattern of these gravitational waves. You can even predict gravitational waves maybe in future with this information. Okay. Then the fourth thing this SKO is going to do is it is going to look for extraterrestrial signals. So you see there are many planets, many galaxies around. So are we getting any signal from them? Is there any signal, even if it's a very weak signal? Now this telescope observes radio signals or radio waves. So if there are any weak radio waves coming from far away galaxies also, it's trying to observe it. The idea over here is finding out any alien life. If there is life existing on any other planet in the entire universe, life of any kind, there must be evolution which has taken place. There's a possibility that these aliens are much smarter than us. They have been evolved and they're having possibilities of potential which is way better than us. That is possible. Now, here we are saying if we could find out such aliens, if they might be sending some signals to us, then we can find out that signal, those radio waves, we can find out using this SKAO. Okay, so all these are objectives of this particular project called Square Kilometer Array Observatory. Okay, now look at this technical part. Here we have dual continent antenna array. So when we say array, it's like we've got so many antennas. See, 1, 2, 3, 4, so many you see. So this is an array. Now what we have done is we have made such antennas or such arrays in two different continents. One in Africa, other one in Australia. Okay, one is located in South Africa to be specific, and other one is Australia. The point is, if we have such long distance and from there if we are observing the universe, this is going to improve our range, sensitivity and the coverage of the sky. That's the reason we have put it in different continents. So that's what we call as dual continent antenna array. Okay. So that's how it works. Why there is a name called square kilometer is because if you see there are so many antennas present in the same locality with some distance. So if you look at it, it looks like a square kilometer area in which there are so many antennas present. That's why the term square kilometer came into picture. Okay. So all the basic parts clear, and is India part of it? Certainly it has recently joined this particular project. Yes. Any doubt if we have on this? No? Fine. Now the next article is related to Artemis mission. This is also very famous. It was in news. Artemis. You must have heard about Artemis mission earlier too. Now, here specifically, we are talking about Artemis Accords. When we say accords, we're talking about some agreements which have taken place, which have been signed by different countries. And accords, we're using accords, not one single accord or one single agreement. So there are multiple agreements which are signed over here with the name Artemis. Okay. Now see, Sweden has become 38th country to sign this Artemis Accord. The first important thing that we need to remember as a matter of fact is this Artemis Accord. It is not a binding agreement as such on any country. It's not binding. It's not legally binding as such. So whether countries want to agree to it, or whether they want to accept or follow the provisions or norms in this accord, it's completely up to them. Okay. And this accord specifically talks about outer space exploration or outer space activities. So when you go to the space, I told you, we don't have any government or any governance over there. So how outer space will work, because different countries are sending their satellite spacecrafts in the space. There's a possibility of conflict in these regions. That's the reason we need some kind of a treaty from from the world side or the international community to deal with all these challenges. Let's say even the example we can take of this space debris. This is a very big problem for us. So we have to consider all these things. For that, this outer space becomes an important area. So United States of America, or specifically to say this NASA and its US Department of State, they both came up with a new idea that we can come up with some agreements. So founding members who were part of this agreement were USA, Australia, Canada, Italy, Japan, Luxembourg, UAE and UK. Okay, initially the idea came, these were the founding members. Later on, other countries also joined this thing. So right now we have total 38 countries who have signed this Artemis Accord, and these are all these countries. I'll give you few seconds, just go through this slide. Just look at the countries who are present in this. Just look at it once. Done? So all these countries are involved in this particular Artemis Accord. They have signed it. India is also a part of this Artemis Accord, is what we observe over here. Now see, when we talk about this outer space, we already had one treaty called as Outer Space Treaty in the year 1967. Okay, now this treaty, if you see, we can observe there are multiple treaties related to outer space. Okay, from United Nations side. One is Outer Space Treaty of 1967. Then the next year we got Rescue Agreement of 1968. Then we got Liability Convention of 1972. It's the same one which I discussed earlier, that if there is a victim in the space sector, let's say a country's spacecraft or anything causes damage to others, then the liability lies on that host country, right? Then we have Registration Convention of 1976 and Moon Agreement of 1979. Out of all these five, India has not signed this Moon Agreement. Neither India nor even USA has signed this one. Okay, rest we have signed, all four we have signed. Okay, now every treaty is important. This is trying to govern the outer space. This part, rescue agreement, it will say that in case there is an astronaut uh, who is having some kind of a problem in the space and he needs to be rescued, in that case other countries or the space agencies of other countries will come up for help to rescue that person. Okay. Then liability convention, I told you. Registration convention, this talks about registering the spacecraft or any devices whichever you're sending in the space. So their standardization should be done, everything should be there, and registration should be there, and this information should be passed on to different countries so that all can cooperate and coordinate. Okay, this moon we have not signed. Now, if we see the key principles when it comes to the outer space treaty overall, what it all talks about or the principles involved over here. First, peaceful exploration of space. Any country going for any activity in the space, they're not going to weaponize it. They're not going to put any weapons over there. They'll go for peaceful exploration. Second, there will be transparency. You have to share all your information, all things with the world community. Then things will be interoperable. Whatever you're making, try to make it interoperable so that you can have cooperation, communication with different countries. Emergency assistance, which we talked over here in the rescue agreement also, that in case someone needs some emergency help or assistance, you should come up and help. Registration will be done, I told you. Heritage preservation, if there is something important you need to preserve it. Let's say USA's mission to moon, where in that Apollo mission, if you remember, so they put their flag over there and all, so that's a kind of heritage, so you should preserve that. Then space resource utilization, this says that all the countries who are going there, they can go for resource exploration. Obviously, if you want to get some resources, get some minerals from moon or anywhere, you can do that, there's no problem. Now focus on this deconfliction point. Don't get into any kind of conflict. And they are also considering this orbital debris management. So whatever debris, space debris is present, for their management also all the countries, all the agencies will cooperate. Now these are all the principles which are part of this, Artemis Accord. Okay, I am saying this Artemis Accord is built on this outer space treaty. So the continuation of this outer space treaty lies in the Artemis Accord. All these are the key principles of this Artemis mission. Okay. Now you can ask if you have any doubts on this. Artemis mission remains important for Artemis Accord remains important for you. Okay, that mission is different, accord is different. See, as far as the PPTs are concerned or the notes are concerned, you can download the Narayana's application. In that application, you will get all the PPTs which I'm showing you here. All the PPTs will be there in that free material section. Okay, that you can download. If you want the compilation wherein you can directly read out the stuff, so that compilation will also be present. Subject wise compilation will be provided to you in the free material section. So you can freely download it from the app itself. Yes, so please ask if you have any doubts. Okay, no doubts, fine. Now let's move ahead with the next topic. Now the name of this article is Earth Care Mission. Okay, we are taking care of Earth? No, it's a different name altogether. Earth Care. Care is a short form. So specifically to say, when we talk about this Earth Care, here this C and A, one represents clouds and the A over here represents aerosols, and this RE represents radiative effect. So you should know at least the basic facts, and then we can tell what's exactly happening in this Earth Care mission. At least know this clouds, aerosols, and radiative effects. So simply, if I have to say clouds, you people anyway know, right? We know about the clouds, how clouds form, that we study in geography anyway, right? The formation of clouds, what all is included over there, the water vapor part or the liquid part, all that. Now, when we talk about aerosols, many students get confused with this thing called aerosols. What are aerosols? Even when we study about pollution in India, we talk about aerosols, aerosol particles. Now, these are very small, very tiny particles. They are either solid or liquid, and they are suspended in the atmosphere. So, in the atmosphere, whatever atmosphere you observe, in that some small particles are just suspended. They are just moving from one place to the other. Now they are either solid or they are liquid, but they are very small. First thing that you need to remember. Now, are they natural? I'll say some of the aerosols are natural, but there are some aerosols which are human made or man made. So, because let's say we have built a power plant from which a lot of smoke is coming out. In that smoke, you might find some aerosols or some human activities from factories and all. Some aerosol particles might be coming out, right? So that's a human made activity. But if you look at some other things, let's say I'm looking at a volcanic ash or volcano eruption, from there many aerosol particles are coming up. That's a very natural thing, right? So this aerosol will be natural as well as human made. Okay. Now, right now, the news that we are observing related to Earth Care mission, this mission is supposed to study clouds as well as aerosols and how they are affecting the climate change. This is something they are going to study. Okay. Now, when you look at these aerosols, natural and anthropogenic, we have a list over here. I suggest you to read this list and remember this list. There can be a direct question on this. Natural aerosols like sea salt, so ocean spray also we call it, desert dust, volcanic ash, pollen, forest fire smoke. All these are aerosols which are formed naturally. We did nothing as such. But there are some which we are generating. Let's say industrial pollutants, vehicular emissions. There's something called soot from the fossil fuels we get it. And there are some aerosols coming from agriculture. Okay, so these are the aerosols. Now, when you categorize aerosols as natural or human made, there is another way to categorize this aerosol on the basis of its property. You see, these are very small kind of particles and they are present in your atmosphere. Now, when sunlight, let's say this is your sun, sunlight is coming in this atmosphere. When it comes to this particular aerosol, okay, now let's look at this particular aerosol. I would say this aerosol, if the sunlight comes, this aerosol is going to reflect this sunlight back to the space. Okay, this is getting reflected. So it's a good thing, because sometimes, because we are getting a lot of heat, sometimes we want that less heat to come to us, so it is getting reflected. Very good, this aerosol is good, we might say. Okay, so there are some aerosols which we call as scattering aerosols. Please remember this term. There are some aerosols which we call as scattering aerosols. What they do is they are going to reflect the sunlight. When they reflect, the amount of energy or the radiation coming from sun, see, from sun we are getting this radiation. Radiation is the amount of energy that we are getting from the sun. Now, because some part will be reflected back because of these aerosols which are present in atmosphere, what will happen? The amount of radiation earth is getting will be less. Now this, because the heat that we are getting is less, that's why there will be some cooling effect. Okay, so the role of some scattering aerosols is to cool down the earth. The best examples of these scattering aerosols are sulfates and sea salt. Sulfates and sea salt, they are the best example. They are playing the role of cooling. Now there are some aerosols, if the sunlight is coming, they are not going to reflect it back to the space as such. What they will do, they will directly absorb sunlight. So these are called absorbing aerosols. So when sunlight is coming, again, these are the aerosols. Let's say here we have the sun, and now the sunlight is coming to our planet earth, right? Planet is heating up. Now already we have got carbon dioxide, we have got water vapor, we've got so many things in the atmosphere. So if I talk about those greenhouse gases and specifically the carbon dioxide, what it does is the sunlight which is coming, or sunlight which is being radiated back by the earth, which has come to earth and earth then gives it back, at that time carbon dioxide captures it. It traps that heat, because of which our planet earth becomes more heated, or it becomes what we call more warm. And right now the global warming that we are observing, it is because the amount of carbon dioxide has increased. What carbon dioxide is doing, it is warming the planet because it is absorbing that heat coming from the earth, right? Now here there are some aerosols in the atmosphere which are directly absorbing the heat coming from sun, or the radiation coming from sun. So if they absorb, that means the amount of heat on this planet will increase. That means it is going to make our planet way more warmer than it is. So the best examples are black carbon, volcanic ash. These are very concerning. Black carbon and volcanic ash. These are going to absorb the sunlight. Clear? Now you can understand. That means the climate change, the global warming that we are observing right now, certainly there will be some role played by these aerosols in climate change. Okay. Now we said, when we talk about this Earth Care mission, it is going to study about clouds as well as aerosols. Okay, first of all it will study clouds, then it will study aerosols, and now after this it will try to know its interaction with the radiation coming from sun. I told you just now that some aerosols absorbing this radiation, some reflecting back. That means their interaction with the radiation or energy coming from sun is very important, and it has some role to play in the climate change or global warming. This is clear. So all this will be studied, whether it is the clouds or whether it's about these aerosols. All this effect will be studied by this Earth Care mission. Okay, so this, now you can at least imagine Earth Care mission, what exactly it is doing. Now if the factual part is concerned, well, it is an initiative from European Space Agency but there is some collaboration between the Japanese Space Agency JAXA and European Space Agency. So through this joint mission, this Earth Care mission is working. Okay. Then it is launched via Falcon 9 rocket from California Vandenberg Space Force Base. Okay, and it will be orbiting the Sun synchronous polar orbit. Okay, so Earth will be it will be orbiting Earth in its Sun synchronous orbit. Okay, it's a polar orbit. So consistently you will get the images of the same place at the same time, and that's how you can observe it better. So the climatic conditions, let's say in Delhi at 12 o'clock, this mission will observe today at 12 o'clock what kind of conditions are there in Delhi. Same thing will be done tomorrow also, next day also. So such things will happen, and this is how this mission will give us some predictions about global warming. Okay, so that's all this Earth Care mission is all about. Yes, any doubt? If you have, please ask about Earth Care mission. No doubt. Okay, good. Now the next topic is about Proba 3 mission. Proba 3. See, we are discussing multiple missions. Tomorrow, when not tomorrow, obviously on Monday, when we'll be coming up with the lecture. In that part, we'll specifically deal with the missions led by ISRO. Okay, at one place when we discuss all the ISRO missions, that would be much easier for you to remember all those stuffs. Okay, so right now we are discussing missions from different agencies. Okay, now Proba 3 mission. This is European Space Agency's. Okay, European Space Agency's mission. Proba 3. Now, they actually had multiple missions. One of that is this Proba 3. And few satellites of this mission, that is the two satellites, are being launched by ISRO. So ISRO is using its PSLV C-59. And using this PSLV C-59, we are launching European Space Agency's Proba 3 mission. Is this clear? Now, just to see the timelines, if we have, first Proba 1 mission was launched in the year 2001. See, European Space Agency is launching, not India. India is just helping them launch through our launch weight. Okay. Now, Proba 1, what it did, it was observing Earth. Its main task was to observe the Earth. And to observe the Earth, it had onboard autonomy. So, it had some components, some robots, or some technical things which could work on their own. We call it onboard autonomy, means they can autonomously work over there in the space. You don't need to do anything from your side. They can operate on their own. Such unit was there over here, and this mission continued remain operation for more than 20 years. Through this Proba mission, they observed Earth. Okay, Earth observation satellite is there. Clear? They're observing, they're coming up with information related to Earth. Then next time they came up with Proba 2 mission in 2009. This time they said, now we are not going to observe Earth. We are going to observe Sun. So they said, whatever happens on Sun, its surface part, what kind of mechanisms are there, all things will be observed. After that, next time in 2012, they came up with Proba V mission. Here V represents vegetation. Now see, here they observed Earth, here they observed Sun, here again they came back to Earth. Now they said now we are going to observe earth, but now they are going to observe the vegetation part. Whatever vegetation is present on earth, different vegetation, different flora, fauna, all that thing, that will be observed and some mapping will be done using proba v mission. Okay, here earth, here sun, here earth. Now the next mission that is there is proba 3. Okay, and here they are going to observe sun again. Okay, earth, sun, earth, sun. Here they'll observe sun. What specifically about sun? Then the answer would be the corona, sun's corona. Now what is sun's corona? Is that is something we all should know. So you observe the sun. Sun has got multiple parts, its core, its chromosphere and all these things. If you see the outer surface, when you see the sun, the outer surface part, here if you observe from here onwards, here you see something called corona, the atmosphere part. Earth has got some atmosphere, similarly sun has got some atmosphere. So that external part or the atmosphere part is called as corona. Okay, it is called as corona. Now in this proba 3 mission, what European Space Agency is trying to do, they are trying to study this corona, and to study they have sent actually two satellites, not single satellite but two satellites, and there's a very good combination. These two satellites are located 150-meter, they're distanced 150-meter, and they are supposed to carry the same distance throughout their mission. This matters a lot. Now this is something we call as precision formation flying. Precision formation flying. So exact precise distance will be maintained by these two satellites anyway throughout the mission, and this is very important. Why this is important, I'll tell you. Let's say you're observing sun, right? You see sun has got some extra layer over here, right? And you see this extra layer, or if you want to observe this corona, you can do that. But observe the light which is coming from entire sun and the light over here. This part will have a little faint light, right? And this entire part of the sun, this part, this will have a very vibrant light. Now you are trying to observe this part, the faint part, right? Or you can see this image, this is the faint part, we can say. Now when you're trying to observe this faint part, it's very difficult. You look at any light source, if a strong light is coming from one source and if you try to observe a faint area which is just nearby to it, you can't observe it because of that strong light. You can't observe because that strong light will have much more effect. Neither your eyes can observe it better, nor even if you take any camera or telescope. You can't, because that strong light will have some effect, because of which you won't see this faint region, right? Now what scientists did? Scientists said, we'll observe it. What we'll do is, we will use two different satellites. Now first satellite, what it will do is, it will just stay ahead, and whatever light is coming from this sun, this part, this light, so this satellite will act as a shield for that light. And just behind this satellite, we'll put another satellite 150-meter away. And here we will have that telescope. Here we will have that camera through which we will observe this corona part which is present over here. Now when this acts as a shield, so that light is not reflecting, not coming up, so the other satellite can easily, or the telescope over here can easily observe this faint region. Okay, easily we can observe this faint region. Now just read the same stuff in a bit technical language. So two satellites fly in precise coordination called as precision formation flying. Okay, aim is to create artificial solar eclipse to observe sun's faint corona. Okay, this corona part which we are studying. So we have got two satellites. One is coronagraph spacecraft, one is occulter spacecraft. This occulter is the first one. Okay, what it does is, it is going to block the direct sunlight coming. So this first one is occulter spacecraft. It will just block the direct sunlight. And this one, coronagraph spacecraft, this is the second one. This is the second one, and here it is going to observe sun in visible light, in ultraviolet light, and in the polarized light. It is going to observe sun, specifically that corona or faint part. Clear? So, if you have ever seen the phenomena of eclipse, it looks somewhat like this, right? You must have observed. Now, that's a natural thing. Here, when we put this occulter spacecraft over here and we block the sunlight, what happens is it looks like this. This part becomes blocked, sun's part, and only the faint part is observable over here, right? So artificially we have tried to create an eclipse over here. So you can say we are artificially creating eclipse, solar eclipse, to study the sun's faint corona part using this mission, Proba 3 mission, which has got two different spacecrafts or two different satellites involved over here. Clear? Theory part, how it is working, that part clear. Now, what will be its use? Whatever studies we will come up with this particular mission, how it will be useful for us. Now, we're going to observe corona part, right? So let's say this is your sun. This is the sun, right? And we are saying here we have corona. This outer part which we see, this is your corona, right? Which is bit faint, we can say. This is your corona. Now this corona is very interesting. From this corona, see the temperature over here is very high. And from this corona, continuously plasma will come out. So some mass, something is continuously erupting from this region, and it is coming to longer distances. Let's say it's reaching to Earth, or let's say other planets. Okay, and because the temperature is high, that's why it will remain in plasma state. It will remain in plasma state. I discussed plasma state in yesterday's lectures, I guess. So now plasma state it is. What we call this particular mass as coronal mass. Okay, and this entire process as coronal mass ejection. So we say when you look at this corona region, from this corona region continuously coronal mass injection, so ejection is happening continuously. This mass in plasma state is coming out. See, when it comes in the plasma state, now it becomes very dangerous for us. See, I told you, solid given some temperature becomes liquid, liquid given some temperature becomes gas, gas given some temperature becomes plasma. And here this plasma is in a state wherein everything is ionized. It has got positive, negative charge. So magnetism, electricity and magnetism, all these effects will be observed in this plasma state. So because of the effect of magnetism, when this coronal mass ejection takes place, and let's say even just one particle of it or one part of it reaches to Earth or nearby Earth, it can damage many things. Let's say we have many satellites over here, we have our power grid, everything can get affected and damaged very dangerously because of this coronal mass ejection. Okay, so we want to study about this coronal mass ejection. We want to know how it happens, how we can stop it, everything we want to study. And that's why this Proba 3 mission will be very much helpful, because it's studying that corona part. Okay, also it will be helpful in the climate studies, especially to measure the solar irradiance. So whatever radiation we are getting, whatever energy we are getting from the sun side, all that will be studied, and that will also be very helpful in our climate change studies, right? So this is all about Proba mission. Now apart from this Proba 3 mission, there are other missions at the global level. You should have a brief idea about these missions. Okay, first is this mission of 1995, Solar and Heliosphere Observatory. Okay, so NASA, European Space Agency, and Japan Space Agency, that is JAXA, all three are involved in this particular initiative. Okay, then next in the year 2006, we have this Hinode initiative or Hinode mission. Here, Japan, NASA, and European Space Agency. Again, the same agencies are involved over here. Okay, all these are sun related initiatives or the missions specifically focusing on observing the sun. Okay, here they observe the effect of space weather on earth. Here they're looking at this solar magnetic field, etc. Right, then we've got one more mission in 2030, interface region imaging spectrograph. This is from NASA side. Okay, then in the year 2020, we have got Solar Orbiter, wherein NASA and European Space Agency both are involved. Then in 2021, we have Parker Solar Probe. Please remember this name, this is very important. Parker Solar Probe from NASA side. And at last, in 2023, we have India's mission called Aditya L1. Aditya L1. Now this L1 term talks about Lagrangian point. So between sun and the earth, there is some location, some area where the gravity of both sides will be balanced. So let's say you're sending something, the gravity will attract sun's gravity. If it attracts something, then that object or that spacecraft or that satellite will directly collide with sun. Same with the earth. So we need a point in this area where the gravity from this side, that is from sun side, and that gravity from the other side, from earth side, both will balance. That area, that point is called as Lagrangian point. So there are different Lagrangian points. Out of that, one is L1, where India's spacecraft has reached. Okay, India has sent its mission. And what we are studying? We are studying solar corona, solar wind, and magnetic storms from this halo orbit of L1. So L1 itself has a halo orbit. From there, we are studying solar corona, solar wind, and magnetic storms. Okay, so you can understand Proba 3 and Aditya L1 both are related missions. Okay, is this clear? Or you have any doubt? No? Good. Now the last one is called as Operation Dronagiri. What is it specifically about? This is a very easy topic to study. So Operation Dronagiri is launched by Department of Science and Technology under our National Geospatial Policy 2022. When we say geospatial technology, geo means earth, spatial means we are talking about the location or the space aspect. So whenever you talk about the location, any location on the earth, then you're talking about geospatial part. So when we talk about geospatial technologies, you're trying to use some techniques, some tools to map and analyze the data which is related to Earth's surface. So any location on the Earth's surface, if you want to map it, if you want to know what is present over there, its temperature, anything, that you can do using geospatial technologies. For example, you have GIS, you have remote sensing, you have global positioning system. This GPS is very famous. Even this GIS is very famous. Government is using it a lot. Or 3D modeling. All these are examples of geospatial technologies. Okay, using this we'll do many things. We'll do cartography, transportation. In logistics we need GPS. Right now without GPS we are not working at all. In agriculture we need GIS system which government is using to know which crop is better or what kind of temperature is there in which locality. Everything, cropping pattern, everything will be checked using this. Okay. Now, regarding this geospatial, we have this National Geospatial Policy under which we have launched Operation Dronagiri. What is the basic idea? See, we are observing Earth, we are getting all this information related to Earth using these geospatial technologies. We are getting so much data, so much patterns, so many things. Now we will utilize all that information, all this technology for citizens to improve the life of citizens. How we'll do that? We'll focus on different sectors. We'll use all these technologies in agriculture, livelihoods, logistics, transport. Everywhere we will try to see some implementation of it. Okay. Now, for example, GPS is just one example wherein we are utilizing all these technologies. Similarly, we'll use all these technologies. Okay. Now, in the first phase of this Dronagiri mission, so first thing is we're going to launch it in a pilot manner. So Operation Dronagiri. First, it will be launched in just 5 states: UP, Haryana, Assam, Andhra Pradesh, Maharashtra. If it becomes successful, then it will be launched throughout India. Okay. Then it is going for PPP model. So public-private partnership is there, just like UPI model. So UPI, if you remember, government or the NPCI brought the foundational model of UPI, and then other companies, private companies, they built their application on that infrastructure. So we have Google Pay, Phone Pay, Paytm Pay, etc., etc. So this is how this Operation Dronagiri is going to work. Government will provide that technology data analysis, whatever they are getting from these technological things, free of cost. The foundational part will be provided, and it is expected from private companies to come up with its application in different sectors. Okay. And for the implementation, we have Geospatial Innovation Cell under DST, that is Department of Science and Technology, and the oversight will be done by IIT Tirupati, Navavishkar iHub Foundation. Now, if you look at our geospatial policy of 2022, its vision, its objectives are very clear. We have to strengthen geospatial sector for India's national development, India's economic prosperity. We want to make India the global leader when it comes to this geospatial sector. We want to enable digital economy. We want to provide citizen services. We want to promote private sector and democratize data. For all this, we are using geospatial technology. Okay, and there is a goal. By 2030, we will have all the mapping data, the topographic mapping data. But by 2035, we will have high resolution bathymetric data. Bathymetric means underwater data, below the oceans, whatever is present. That data is needed, whatever is there, what kind of landscape is there, what kind of flora, fauna, what is there. Every data we will get from here. Then subsurface mapping, that means below the ground. When it comes to continents, below the grounds, what kind of minerals are present where, every data we will get from here. And there's something called digital twins. This is very interesting. See, we have a city in which we have many roads, many people, so many people, so much traffic is there, everything is there. Now, if I make a computerized model of all this, okay, a computerized model which looks like a twin of this city, when I will have all this traffic, all so many people, so many roads, so much infrastructure, everything. Now, through this model, I can come up with the data patterns, and I can come up with some solutions which I can utilize over here in real life. This is called digital twin. So, with this Operation Dronagiri, we will have all this in future by 2035. So, this is very important. And to implement it, we have some institutional structure. Let's say we have this Geospatial Data Promotion and Development Committee. That's an important body. We have Department of Science and Technology, which acts as a nodal agency. This digital twin I have already told you. Then we have geospatial knowledge infrastructure. Now here we are trying to utilize the technologies of present time. So Industry 4.0, we say web, cloud, networks, all this will be integrated. And we have geospatial education and skill development, wherein we will try to standardize the curriculum related to this geospatial technology and integrate with innovation ecosystem. So overall, please focus on this policy, and please focus on this geospatial technology aspect, and remember its importance. That's it. Okay, so we've completed this part, and today we'll stop over here. We'll continue the space technology part in the next lecture too, and we'll cover the entire theme of space technology. Okay, so with this, I'll wrap up the session. We'll meet in the next session. Thank you so much for joining.